Our next speaker is Carmine Grasso. Carmine is a Chief Geologist in the Geological Survey of South Australia with more than three decades of industry experience in the onshore oil and gas industry. His more recent experience is in exploring, appraising and developing onshore oil fields in Australia, including the Mereenie oil and gas field in Central Australia. Today, however, Carmine will be presenting on the Cooper Basin. Welcome, Carmine.
Thank you for that. Welcome to my talk today. And so why am I talking today? On the left-hand side, this is information that's obtained when you drill a petroleum well. It's a mud log. What we see there, highlighted in red, the total gas curve, that looks okay. Next to it is the fluorescence. It's only traced to 10%. That's actually quite poor. It's not what we expect. But next to it, we've got the breakdown, C1s to C5s, the heavies, C1 being methane. That looks quite interesting. Then we get our electric logs, but we notice that the resistivity is only 3 ohm metres. Generally, that's water. But the zone looks of interest, so we give it a go. And voila, this one gave us oil. Hence, borrowing a line from a Paul Kelly song, today's talk is "From little things, big things grow." So that's the agenda today. Mainly it's going to be spent on the play itself, what it actually is, and then obviously where it is today, what's being produced and what areas can still be exploited. So where are we located? Unlike Chris, who's down to the south, we're up to the northeastern corner of South Australia. On the right-hand side, the most area of interest, what we're looking at is a reservoir that sits in the Eromanga Basin, and what's important is the Eromanga Basin that overlies the older Permo-Triassic Cooper Basin, which is important as the source rock. So we look at the stratigraphy. What we see on the left-hand side, we see down at the base, the Cooper Basin. That's important as providing the source rock. It's been overlain by the Eromanga Basin. Predominantly, most of that is non-marine. However, there is a period in the later stages of the Eromanga Basin where we get a marine succession that's developed. What we see as part of the relative sea level fall, we see that, relative sea level rise, that we get an Eromanga seaway. On the right-hand side up the top, the Coorikiana sandstone gets deposited. So essentially it's a marginal marine sandstone surrounded by marine shales, overlaying and underlaying. It's essentially very fine-grained and glauconitic in nature, but it can provide our reservoir rock. It's about 35 metres in thickness as we head towards the Queensland border, generally about 20 metres. As I stated before, we're dealing with an Eromanga Sea before the Coorikiana sandstone is deposited. Around about 105 million years ago, we have a relative sea level fall, and what happens there is that allows the sediment to basically prograde seaward. And what it does, it deposits our Coorikiana sandstone. And our Coorikiana sandstone is essentially a marginal marine shallow environment of deposition. The examples that I'll show later come from that part of the map, the paleogeographic map. So now the play concept itself. So I'll go through trap, seal, reservoir, source, charge and migration. The first part is trap and seal. So what we have there, on the top right-hand side, the Coorikiana sandstone is being deposited into our basin. It obviously shales out as you head towards the basin centre. It's then also overlain by the Unadata Formation, which is a marine shale. It also overlies the Bulldog Shale, which is a marine shale. So these are sort of very fine-grained sediments, very soft sediments. We have continual deposition of the younger part of the Eromanga Basin, and then we have the Lake Eyre Basin that's deposited over the top of that. Through a process of dewatering, compaction, tertiary faulting, and squishing of the rocks, we get what looks like horse and grabens. It's not really horse and grabens. We get what's called polygonal faulting that occurs. And what we end up having is this Coorikiana sandstone that's offset from its nearest neighbour. In plan view, when you map this zone in seismic, it has more of an appearance that looks like mud cracks. I need to note that mud cracks form under a different process than the Coorikiana sandstone polygonal faulting. On the left-hand side, that's a typical seismic section in our Eromanga-Cooper Basin. What's important there is essentially those green lines, the green faults that cut the yellow reflector. That's the Coorikiana sandstone that gets mapped in 2A time. What's important to note there is the green faults that actually penetrate deeper down into underlying deeper hydrocarbon gas or oil pools. The right-hand side is essentially shows you when you map that reflector, that's what it looks like in 2A time, and then that's a depth map. You can see it's got a bit of that mud crack looking look to it. The next one's the reservoir itself. Essentially, when you're within the Coorikiana sandstone fairway, which is highlighted there in yellow in the central part of this slide, it's ubiquitous. The only time you will not get this reservoir is when you drill through it and you happen to go through a fault, which I showed previously. So if you avoid the fault, you will get the reservoir. So the reservoir is essentially given. Then it will depend on reservoir quality. What's shown on the right-hand side there is essentially one of the discovery wells, Udanata 1. What's important is that you don't look at these electric logs, gamma ray resistivity, gamma ray on the left, resistivity on the right. You don't look at these logs with the conventional scales that are typically used. So gamma ray, instead of 0 to 200, you have to use something like 50 to 100 GAPI units. And when you do that, you can see a lot of character in the reservoir. It is high gamma ray due to the very silty nature of the reservoir and its complex mineralogy. That also affects the resistivity. So resistivity can't show it on the standard 0.2 to 2,000 ohm metres. What I've shown here is 0.5 to 10. When you do that, you can see that the reservoir does actually have some separation. That separation is a good indicator of permeability, that there's a chance of hydrocarbons being placed in that reservoir rock. Going on the reservoir again, this is just a schematic. We've got a section here that goes roughly north-south. So as we head to the north, we're heading to the basin centre, the deeper water where the reservoir shales out into the shale, the marine shale. But we can see that essentially we have a reasonably consistent reservoir. There's 2 cycles through here. The lower cycle being the thicker, the one that has more gross rock volume. However, the top cycle sometimes can have the better reservoir quality. So now, all the wells that have been drilled through the Coorikiana sandstone, obviously going for deeper targets, less than 1% has been cored in this basin. This is an example of an oil well, left-hand side under natural light, right-hand side under UV. What we see from here is when you've got enough permeability, hydrocarbons get into the rock, and of course this one here, we've got oil in the rock, which is shown by the fluorescence. When you look at the sedimentary characteristics and the microfossils, it's indicative of a shallow marine shore face sand, that you have mixing of fresh water with seawater. So we're not deep, we're not way offshore. So now we move on to source, charge and migration. The surrounding shale of the Coorikiana sandstone, Udanata Formation and Bulldog Shale is immature for hydrocarbons. So what we're looking at an example of where we've found oil. It's called the Jalbu complex. It's roughly 20 to 30 kilometres south of the Moomba. That's a typical gas chromatograph of an oil in that area. I've just highlighted the C15, C25 as goalposts. C17 as a marker because the peak is just to the right-hand side of C15. So these are now oil pools that sit deeper below the Coorikiana sandstone on this complex. So that's the general shape that you see. Now if we get oil that's been produced from the Coorikiana or from drill stem tests and analyse it, we see we have basically the same shapes. The oils are the same as the ones below. Same sort of low 40-degree API, pour points around 20 degrees centigrade, and can have a reasonable high wax content. The plate concept itself. So now, for gas, we've got to get gas deeper down. Comes up via faulting into the overlying Coorikiana. Similar for oil. So now we'll just look at a section AB. So section AB will show it in cartoon form. So what we have here is migration. Essentially, this fault cuts down into the deeper oil pool, moves up the fault, and fills up our Coorikiana sandstone. Once it's done that, it will move laterally by juxtaposition of reservoirs until there's no more charge to feed this reservoir. For gas, where the gas has been discovered in the Coorikiana sandstone, this is an area that's northeast of the Moomba area. We've got a major fault. So the gas comes from the Cooper Basin, it sources our Eromanga Basin gas pools, and then that migrates further into the Coorikiana sandstone, which is our shallowest gas and oil pools in the basin. Oops. Okay, so where are we at production-wise? Discovered in 81. Took 17 years before they decided to produce the first gas from this zone, because essentially it was the poor second cousin to the deeper horizons due to rate and reserves. 5 years later, there's a dedicated gas well. So essentially, every time there's a program that's been planned, there's been an uplift in gas rate and obviously production of gas. Similar story for oil. Once again, discovered in 81, took 22 years before oil was first produced in Yolandi 12, 30 barrels a day, not exciting for management. 25 years after first show, the first dedicated oil well, which is Unadata 1. And with subsequent programs, 42 years later, we've reached peak rate of the Coorikiana sandstone. Like I said, from small things, little things, big things come. So now, my last slide. The left-hand side shows you the play extent. So that's the area of interest to explore for the Coorikiana sandstone for oil and gas. Right-hand side there, essentially that's an area that shows the play, highlighted in the red polygon. And currently, majority of that area is covered by licenses. However, there is a small section around what's called the Dunoon Horse that's available for explorationists. And essentially, something that's been ignored for so long, in more recent times, it's shallow and can add value to companies, which means producing more gas and oil from these zones, which is obviously royalty for the state. Last thing is there is I'm not going to click on the link. Essentially, there's a booklet on the DEM website which has a lot more detail than what I've presented today. And that's it for me. Thank you very much.